Hitting record. Our second objective of practice test B, stoichiometry, asks us to use stoichiometric quantities from balanced equations in terms of moles, mass, or particles, and volume. When we write our equation, the equation that we write number 1 will be carried through for all of the problems underneath. Might I stress the importance to make sure you get your stoichiometry correct so you don't carry a mistake over into the math. So we'll take our time and make sure that the problem, the formula, is written correctly. We want to write an equation for the reaction of gaseous fluorine. Fluorine is F2, belongs to the Lucky 7 Club, and I'll put the little gaseous sign next to it, with aqueous lithium chloride. Lithium who's a +1, chloride who's a -1, so we write that LiCl. This pattern of chemical change says we have an element reacting with a compound. Element plus compound is known as a single replacement pattern. I also noticed that the element is a nonmetal, so I compare it to the nonmetal in your compound. Fluorine has to displace chlorine from the compound, so I check the nonmetal activity series, and indeed it does. Fluorine's at the top of column 7A. Fluorine is the strongest halogen. It would kick out the chlorine. So on the product side, chlorine is now by itself. It also belongs to the Lucky 7 Club. And lithium is the positive ion written first. Fluoride is the negative ion, hooking by charge. Cl2 plus LiF are the products for this single replacement reaction. We would balance by placing coefficients of 2 in front of our compounds, a 1:2 to 1:2 stoichiometric ratio. The problem number 2 reads, how many moles of fluorine gas, so that's our want, are needed to form 84 moles of lithium fluoride? Given a mole, calculate a mole. We call those mole-mole problems. As usual, I always start by writing my number, 84. The unit after it is a mole, and of what is lithium fluoride, LiF. On my stoichiometry roadmap, I begin right in the heart of our problem. We're at moles of given. I don't need a first parenthesis because we're already there. I'm asked to go as far as moles of fluorine gas. So what I'm being asked to do is just the heart of our problem, the want over given. It's a 1 parenthesis job. Given a mole, calculate a mole. And our target is the fluorine gas, F2. I place my want over given stoichiometric ratio, which is just fancy for saying grab the coefficients. If we want the fluorine, its coefficient is 1. Set over the given, its coefficient of 2. We have a 1/2 mole ratio of want over given. When I hit for this, I just simply take 84, divide by 2, and we come up with 42 moles of fluorine as our answer. So a 1 parenthesis job for a mole to a mole. In our next question, it asks us to calculate grams of lithium chloride necessary to produce 37.2 grams of chlorine. In this problem, we'll begin by writing our number 37.2, the unit gram, and the label would be chlorine, Cl2. We're being asked to go to grams from a gram. So if I look at my stoichiometry roadmap, given a mass, calculate a mass, it's all 3 steps of stoichiometry, where we have to divide, ratio, multiply to move from the left to the right. I like to get those 3 parentheses ready so I can see my target where I want to go. And where we're being asked to go is grams of lithium chloride. So I can see my target, and that middle parenthesis will be the heart of our problem, the want over given ratio. In our first conversion factor, we need to change the gram unit of chlorine into a mole unit, so we'll use its molar mass. Adding a couple of chlorines together gives us 71 grams as its molar mass. Our target is lithium chloride. Its coefficient is a 2. We began with chlorine, Cl2, its coefficient is a 1. Our stoichiometric ratio is 2/1. The last little bit we'll need is a molar mass. I'll add that. 7 for the lithium, 35.5 on the chlorine. Looks like 42.5 grams of lithium chloride fluoride in every 1 mole of lithium chloride will take us out to grams of the reactant LiCl. So I'll hit 37.2, I'll divide by 71, times 2, times 42.5, and I get 44.54 grams of LiCl. Question 4 reads, how many formula units of lithium chloride are necessary to completely react with 394 liters of fluorine? Given a volume, we want to calculate formula units. Just thinking about the stoichiometry roadmap, we're starting at volume and want to work to the number of units. So I have 3 parentheses where I use molar volume in step 1, the ratio in step 2, and it looks like Avogadro in step 3. And we'll land at the formula units of the product. So 394 liters of fluorine is our given. I'll get my 3 parentheses ready so I can see the target formula units of LiCl. The middle of our problem will be the want over given stoichiometric ratio. Since we're beginning at a volume unit for fluorine, we'll use molar volume of 22.4 liters to convert. Step 1, divide by the 22.4. We'll then need the ratio in step 2. Coefficient in front of our lithium chloride is a 2, so 2 moles of LiCl will be placed on top. We'll set that over the coefficient in fluorine is a 1. 1 mole of F2 on the bottom. Our want over given ratio looks like 2 over 1. To count the number of formula units, we'll use Avogadro's number, 6.02 times 10 to the 23rd formula units of lithium chloride in every 1 mole of lithium chloride. Bless you, by the way. We'll divide, 394 divide by 22.4 times 2 times Avogadro. Then I found 2.1 times 10 to the 25th formula units of lithium chloride. One more will finish off this objective, yet another journey using our roadmap. Here we're being asked to find liters of fluorine necessary to produce 5.1 times 10 to the 26 formula units of lithium chloride. So we'll start by writing our number, 5.1 times 10 to the 26. The unit is a formula unit, and the label there would be LiCl for lithium chloride. Our journey looks like we're starting up here at particles, and we want to bring it to the volume, which is down at the bottom of the right-hand side. Step 1, step 2, step 3, where we use Avogadro, then ratio, then molar volume. I'll get those 3 parentheses ready. Step 1, step 2, step 3 is where we see the target is lithium or liters of fluorine. In our first conversion factor, we'll say 1 mole of lithium chloride would have an Avogadro's number of formula units of lithium chloride. The ratio of want over given. We want fluorine, its coefficient is a 1. From the lithium chloride, its coefficient is a 2. To bring it out to volume in our third step, we'll use the molar volume of 22.4 liters of fluorine